Well, I just did something really stupid. I was testing out some SSDs, some NVMe, PCIe NVMEs, and I chose the wrong partition to delete. In fact, I chose the wrong disk to rewrite the partition table on, and I erased all of my video data and a lot of my pictures and a lot of my backups. They were all on that drive and they're all gone. Now, luckily, I am using a partition recovery tool right now. It's going to take about 24 hours to chug through this huge disk that I have all this stuff on, and I should be able to recover it. At least, fingers crossed, I'll be able to get all my data back. But as penance for that, cross my heart if you're Catholic or something. I don't know what Catholics do, but as penance for that, I am going to be taking a look at this big box of disks that I bought and testing them all out to see if they work. That is my penance today for the stupid mistake that I just made. So that's what we're going to do today on Retro Hack Shack After Hours. So I was able to pick up a big box of hard drives that hadn't been wiped yet. I don't know how they've been handled. There are mostly IDE drives in there. I tried to weed out all of the SATA disks because I want older disks. And I even found some MFM type hard drives or RLL. I think they're MFM because they're super big, but I don't know if those are going to work either. Anyway, I need to test all of that stuff out. I like using those old hard drives in some of my builds from time to time. It's kind of fun. Even though they're not the fastest and stuff, it still is very nostalgic. And if I can save a few drives to use on the channel now and then, you know, why not? They'll eventually go bad. It's all spinning rust. But in the meantime, maybe I can save a few and maybe even discover a few hidden gems along the way. And a lot of times these old drives will have software that, you know, maybe doesn't exist other place else. So it's nice to archive that when you find it. So that's what I'm going to be trying to do today. And I wanted to go over some of the tools that I use to do this with. The first one is a USB to IDE or SATA converter. It's a little adapter. This one is the current one that I'm using. It's made by Unitech or distributed by Unitech. It's probably rebranded from something else. Got this on Amazon. The reason I got it is because I did want to use or have one that would run fairly quickly to keep up with SATA speeds. And so this is a USB 3.0 device. So there should be no limitation in terms of transferring files or anything like that because of the speed of the USB connection. But this is the current one that I have. You can take a look at what's inside. It is exactly what you would think. There's a power adapter here, and there is this little adapter that plugs onto, oh, I have one over here actually, plugs onto a hard drive like this. And if you're using SATA, then you would plug it in. Actually, that's for the smaller IDE, and then SATA's over here. You would plug that in that way. Plug that into your disk, power it up, and hook it up to your USB. And if it's working, you can see if that disk is working and what's on the disk. So this is the tool that I use most of the time. Now, this comes with a little adapter here to power up the drive, but I also have a standalone 5 and 12 volt power adapter as well. Sometimes it's easier to use this versus the other one or whatever, depending on how tight the connections are. So I've got that standing here or in standby here in case that I need it. Now, what I'm going to be using to read these things with is a machine running Linux. This is very important actually because you can get a lot more information out of a Linux machine for what it sees and what's going on in the system than typically you can out of a Windows machine. I know these days there are pretty good tools, I'm sure, utilities that you can download from sources, whatever, but these tools are actually built into Linux or you can get them really easily. So there's two tools I'm going to be using today. The first one is actually the tool that just I used incorrectly. It's not the tool's fault. I use this tool to do the damage to my hard drive. But yeah, this is a tool called GParted, and it works really well. You turn it on and it will show you all the hard drives that it can see. In this case, there's only one right now, and all the partitions, and you can repartition things. You can move things around. You can resize the partitions on your hard drive. It's a really, really great tool, and I've been using it for years. But what this will do is this, unlike a Windows machine, which would not show either Unix type file systems like ext type file systems or Sun type file systems or things like that. You wouldn't see those on Windows, but you will see those on Linux. It'll pretty much tell you any kind of partition or data scheme that's on the disk. So really, really useful. And then also I'm going to be using the command line, and the command line is going to be useful because when I plug in the drive, I want to be able to see exactly what happens, and if there's any error messages, what the error messages are. And I'll be able to do that easily from the command line, and I'll show you how to do that in just a minute. Hooked up the adapter, powered it on, waited for the drive to do its thing and settle down, initialize, and now I can go ahead and turn the adapter on. And when I do that, there are a couple of things just happened. So I was listening for, when I turned this adapter on, I was listening for activity, read activity on the drive, and I did hear that. I also heard a little doink on the laptop here. So now what we can do is we can use two tools. The easiest one is just to go over here to GParted and hit refresh devices. Oh, and I can, as soon as I did that, I could hear it start reading this drive. So this drive is actually working. And now there should be in this drop-down a second drive. Here it is. So this is a 1.2 gigabyte drive. And on there we have a couple, one partition and then some unallocated space. And this partition has it's a FAT16. So this is probably Windows 95 or DOS drive maybe. Must be Windows 95, I would think, or maybe 98. And it has a label called Sylvan. So this is looking like a good drive. It's about halfway filled up with data. So yeah, this is looking pretty good. If it wasn't working, what I would do is I would come over here to the terminal window here, the console, and I would type in dmesg. That will give you basically the last little bit of information, whatever events happened on the system. And if we run that down here, we can see that there is attached SCSI generic SG0 type 0. So this is all kind of a normal output here. Write protect is off, blah, blah, blah. Attached SCSI disk. It's not really a SCSI disk, but that's just what it says. And then it's got some other messages there as well. So yeah, those messages up there are pretty normal. So that's telling me that there is a drive attached, and it didn't have any problems attaching that drive. Now, I think Linux should be still able to read FAT16 disks, and usually when it can read the partition, it will actually go ahead and automatically mount the partition, and it'll pop up here with an icon. Unfortunately, when I tried to mount this particular device so I could look at the files, it gave me an error, and so I decided to try another tool on Linux that works really well for diagnosing problems, and that's called Testdisk. All right, well, this partition, this drive actually is kind of toast. So I did some digging. I pulled out Testdisk, which is a great utility for Linux because it lets you fix file systems. It lets you even pull files. I can actually see the files in the partition. There's a lot of check disk remnant files on here, so apparently this particular drive must have been having problems at some point. But I can tell this is Windows 95, and I can even go in here and see the data on the drive. I can go into my documents, and there's instructor schedule, Claremont Middle School.doc. I'm not going to go into all the personal detail, but what this tells me is that this was probably used in a school. This drive came out of a school computer running Windows 95 at some point. These documents were from 98, 99, 2000. So unfortunately, though, the boot sector of this disk does have a problem. It could be a bad block or something, but it's getting some weird errors. And when I try to rebuild that, I actually get this information that it can't get the cluster size. So yeah, I'm not going to go any further with this particular disk, but Testdisk is a great tool to recover partitions and things like that on drives where you may have some valuable data. In fact, I'm going through this process right now on that drive that I blew up on my main editing machine. So anyway, I'm going to mark this disk as needing to be completely wiped. I think after that, it may go ahead and work okay as long as it can identify perhaps a few bad blocks on the disk. I just found another really cool drive here in this box, but before I get to that, I want to thank the sponsor of today's video, PCBWay. PCBWay offers inexpensive PCB manufacturing and a whole lot more. Need assembly services? No problem. They can do front side, back side, through-hole components, you name it. They also offer 3D printing, CNC milling, and more. So check out PCBWay for your next project, and I thank them for their support of the Retro Hack Shack. Now, here's something interesting. I don't know if you can tell, but this has a bigger form factor, and you might remember these from back in the day. This is a quantum Bigfoot drive. And these were drives that were made to fit in a 5 1/4 size bay in your PC. Not only that, but they used larger platters because at this point their data capacities were a challenge. And so Quantum decided to use, I believe, larger platters are in here, 5 1/4 inch platters, which allows them to get the density of this particular drive up. I think depending on what cylinder head and sector size, I think this goes up to 6.4 gigabytes perhaps, but it was bigger than its 3.5 inch relatives back in the day. Eventually it just got too costly to produce these, and so they went out of style. But there for a while, these, if you wanted high density disk drives, this was the way to go. I wonder if these are still working. Okay, I just did get the dink sound, so I think we have a drive. Six gig drive, only 1.2 gigs, FAT32 file system on here. So far this is looking good. Let's see if we can mount it and check it out. Looks like it's working. Let's just see what the dates are on these. So yeah, this was used into the 2000s, 2000, 2001. I'm not going to reveal any personal information here, but yeah, it does look like it was working and running some version of Windows. But yeah, this disk is absolutely working. The Bigfoot is still running strong. Okay, well here's something you don't see every day, but they were around, and that is a Apple drive. It's got the Apple logo on it, and it is a Quantum drive who made a lot of drives for Apple. It appears to be functioning, and certainly when I go into GParted to hook this up, it says HFS hard drive. So definitely an HFS partition on there. It can detect that, but it can't really read anything about it because I do need to install something called HFS utils in Linux, which I guess isn't installed by default, but I'm ready to install that now. There we go. HFS utils is installed. So hopefully we can see from Linux what the data is. And this is what I was talking about before. There may be utilities to do it these days on Windows, but this is a great way to be able to look at these drives that have all sorts of stuff on them in Linux, even the Apple drive. So let's see if I reboot GParted, maybe it will allow me to do something with that disk now. Well, it's still complaining about not being able to read the contents of the file system. Let me see if it'll mount. Okay, it did mount. So let's go ahead to the browser and see if it can see it. Yeah, sure enough. So now we're reading an Apple drive on a Linux system, an old Apple drive. Let's see how old it is. Let's see how old these files are. Yep, so these go back to 99, 2000. So I'm, not the best Mac person. What is this, maybe like on a Quadra system or something like that? I don't know. But we've got, desktop files on here. We've got After Dark, screensaver, I'm assuming. In documents, there's a bunch of documents in here. This says Performa ClickArt, so maybe this was a Performa system. Yeah, a bunch of personal documents that I'm not going to open up or go into really, but yeah, it looks like some receipts, stuff that you would typically have on your system. Something called Sweaty Palms. Ooh, I definitely don't want to know what that is, but anyway, it looks like the disk is certainly working, so I'm going to mark this one as good. As I worked my way through the rest of the IDE drives, I found a few that were either slow with the motor starting up or perhaps weren't spinning at all. Usually with those, if you let them warm up, or the ones that won't spin, if you give them a little twist with your wrist or a little knock on the side with a screwdriver, that sometimes frees them up. And I had a few that were like that and came free. Now, that'll leave some bad blocks potentially, but at least it'll make the drive usable again, and maybe you can get some data off it. Okay, well, here's where I've gotten to so far. I've tested all of the IDE drives, and out of all of them, 12 of them are actually working, including the 3 Bigfoot drives down here, and 2 of the 2.5-inch drives were working, one with OS X on it, one with Windows 95 on it. And then I have 10 non-working drives, so I have a better than 50% average so far. But these 2 stacks and this big drive here are SCSI drives. So those I will have to set up another Linux system, because there's no really good USB to SCSI conversion device for cheap anyway that I've found. There were a few floating around on eBay for hundreds and hundreds of dollars. But you can easily get an older system set up and put a SCSI card in it like I have, and you'll be able to read these SCSI disks just fine as long as everything's working. So what I have is a motherboard from 2007, at least that's when the manual was dated that I looked up. This is a Core 2 Duo, and forget the exact model number, but it doesn't really matter. I've got 8 gigs of RAM on this, and I have attached a SATA drive because this motherboard is new enough that it does support SATA as well as IDE and floppy connectors, by the way. Very nice motherboard. If you've watched my show in the past, whenever these have come up, you know that I actually really like these motherboards because they support the older equipment. They support PCI slots, which I'm using for the SCSI card. So really like this, the ability of these types of systems to test things out. So what I've done is I've gone ahead and loaded Linux. And the nice thing about Linux is it really runs well on older hardware. So this is the very latest version of Linux Mint from, I don't know, a month ago or something. Loaded it up, works great, even on this hardware from 2007. No performance issues or anything like that. Of course, I'm not trying to watch 4K videos or play games and stuff on it, but it does load up. And the other nice thing about Linux is it does a really good job of detecting hardware. So, and having drivers built into the kernel for that hardware. So it detected this SCSI card. This is an Adaptec 2940 or something like that. I can't remember exactly, but it detected the card. And I had it in here when I was doing the installation. So the first time I booted it up, recognized the card, no problem, and everything is working great. Now, in terms of the tools that I'm using, they're primarily the same, except for one additional wrinkle. Well, 2, really. The first one is the SCSI drives themselves, of course, need to be terminated. So if you don't know much about SCSI, I'm not going to go into a long technical explanation of it here, but it's a nice, fast bus that has the ability to support multiple devices, not just 1 or 2, but up to 15 devices technically on the chain. The only issue is that you need to be terminated on one end of the chain and the other end of the chain for this to work. So you put a bunch of devices on there. If you don't have your termination right, the system won't see them or you'll get an error. So you have to be terminated. And I'll show you an example of what that looks like on some of these older drives. So you can see on this particular drive, there are these, looks like pin header holes here, but they're actually press fit kind of holes here on the board, and that is to stick terminators in. In fact, I have some right here. This isn't the exact right one for this particular board, I don't think. This one requires 3 terminators in it, and this came out of a drive that has a similar setup but only requires 2. And they look like this. They're like little resistor networks, and they have a particular termination value, which I'll put up on the screen probably at this point because I forget what it is off the top of my head. But those get pressed into the device that's on the end of the chain. If you had more devices than this on the chain, you would take the terminators out of the ones in the middle. So the one device on the end or either end of the chain, put the terminators in. The ones in the middle don't have the terminators. And very much like old school floppy drives as well, use that technique with terminators in them. But that's one thing that you need to be careful of, and not all terminators look the same. So for example, in this particular device, which is comes from Magnetic Peripherals Incorporated, that's one that I have not heard of. It says a control data company. Magnetic peripherals. I don't know if I've ever ran into a device, but you can see down here, this is actually for an Apple computer. It's an Apple logo, hard disk, 160 SC, so it's 160 megabytes most likely. The 5.25-inch SCSI drive. So this thing is huge, it's heavy, but it has different terminators. If I turn this over, there's actually 3 terminators up there, and I actually took the terminators out of that other disk that I was showing you just a minute ago and put them in here to make this drive work. I should mention as well that most of these drives have some sort of jumpers on them where you can select various options as well as the drive ID, because on that chain, as well as having the termination ID at each end, you also need to specify the ID for each device that's on there, and it needs to be distinct from all the other devices. So you can set it up for ID 0, ID 1, and so on, all the way up to ID 15. So I guess that's a total of 16 devices, including, of course, the card itself that this is going to plug into. That is a device as well. So yeah, you're going to have these jumpers, so you need to pay attention to those and make sure that those are set correctly for what you're trying to do. So termination is one thing to keep in mind, and the other thing is that there's an additional utility that we now have at our disposal with most SCSI cards. All the ones that I know of that I've used have a built-in BIOS utility that starts up when the computer starts up to recognize the devices that are connected to that SCSI bus. And at least the one that comes with this particular card that's built into it also allows you to do a couple of things. So let me plug in this card, and then I'll go through the process of how I test this drive up. The interesting thing about this particular drive I noticed as I've been testing it here is that it doesn't actually start spinning until the SCSI BIOS loads, which it just did. And you can hear it kind of taking off like a rocket ship there. And it does come up. It says the vendor is CDC. It gives me a product number and then goes into this, but I don't want it to go into that. I don't want it to actually boot up because I want to show you what the SCSI utility looks like, which is a resident on the BIOS on the card. Now, most of the SCSI drives I've worked on, they just come up right away. I'm going to hit Control A here. The motor has started as soon as it gets power, but this one waits until it gets interrogated by the SCSI card. To see if it's, to spin up rather. Now this comes up with the model number of the card here. So this is a 29160N and A. I don't know if the A is important or not. That's slot 1, so it tells me what slot it's in. If I hit enter there, I get a couple of options on the, in the SCSI utility. So I configure all the settings for the particular SCSI controller, which I'm not going to go into right now, but I can also go to the SCSI disk utilities. And there again, it's going to do a scan of all the devices that it can see on the chain. And in this case, it sees the Adaptec card itself as one of the devices. That's SCSI ID 7. And it sees this CDC drive, or whatever it was called, Magnetic Peripherals Incorporated drive, is set for SCSI ID 1. So this is a good way to verify if the drive is working at all, is to just see if it comes up either as the system is booting or in the SCSI utility to see if it comes up. And there are a couple other things we can do too. If I click on this, there's a couple things to do. There's one is to format the disk. So you can do a low-level format on this drive. The other one is to verify the disk media. Now, both of those take a while to complete, so I'm not going to go do it now, but I've already run through a few disks on here that were questionable, and I did do the verified disk media. Some of them were completely bad, failing on every track, so they probably had bad tracks or scratchy tracks inside the inside on the platters themselves. And then another one I did a low-level format on, and it came up okay after that. So these utilities can be really handy, and this is even before we get into the operating system itself. So let me back out of this. Now we'll boot up Linux and see what's on this drive and if it's really working or not. It feels very odd for me out here to be using a USB keyboard and a wireless USB mouse. I guess you know, if you're really a vintage computer enthusiast, if you have a hard time finding the modern peripherals that you need, even from 2007. And as this is booting up, I'm hearing it start to access the drive. I can hear the drive heads moving around, doing some sort of either initialization or data seek, probably getting probed to see what partitions are resident on the drive. Okay, so now that we're back in Linux running on this machine, I can actually use the same exact tools that I would before on the IDE drives. And let me pull those up. So I can use dmesg if I'm curious if there were any errors or anything major that might help me debug anything on this. But I'm not seeing any errors in dmesg. Also, I can use sudo fdisk -l. Now in this case, sudo fdisk -l shows me that this device is here. It's registered as /dev/sdb, 170 megabytes. But it does not show me the partitions, interestingly enough, for this SCSI drive. But if we go over here to GParted and select that same device, /dev/sdb, now I can see that indeed there are 3 partitions. 2 of them are unknown. And then this last one is an HFS partition, which would be an Apple partition. So again, since Linux supports all of these things natively, we should be able to mount. In this case, this device is /dev/sdb1. So I'll mount that using sudo mount the device name, and then I'm going to mount this on /mount or /mnt in this case. So now that it's mounted, we can go ahead and go into the file system and go to that directory. And here it is. Here is the contents of this disk that we're seeing. So yes, indeed, this is an Apple disk, and we can see Apple extras, applications. I'll go back to that in just a second. And here we go, about system 7.5.5. So this particular drive, I'm assuming it could have been upgraded again after this, because it looks like it was upgraded twice. Here's system 7.5 and then system 7.5.5. So it could have been upgraded several times, but at least I know it's in the 7.5 range, this particular drive. And again, not going to show any personal data, but you can go into applications and see kind of what this thing was used for. Here's Aldus PageMaker 4.2, FileMaker Pro 3.0. You kind of expect to see that on systems of this age, very popular applications, and Microsoft Works 3.0 as well. So yeah, they're definitely an Apple drive, and we could connect this to a system of this vintage and boot this up, and it should come up and work fine. At least it seems like the system itself is, or the drive itself is okay and running fine, and we can see all the files on it. One downside to running a system like this with this configuration versus the adapter, the USB adapter I had before, is that I can't do an online swap of the drive. So I do have to shut down the system and then change the drive out when I'm going from testing one drive to testing another. I've got to actually shut the system down, and that does take a little bit because it takes about 90 seconds or so, maybe 2 minutes for the system to boot off this particular hardware. But yeah, at least it gives me the option to test these drives, even if I don't have the plug and play nicety that I had with the USB adapter. So I've gone through most of these drives already, but there are a couple that I wanted to point out in addition to that big one I was showing you before. One of these failed drives, actually a lot of these SCSI drives make a lot of noise even when they're working. This particular drive is not working. It's not showing up at all. It's got the proper termination, but it just doesn't work. But I just wanted to show you how loud this thing is. I don't know how loud this is going to come across. Mosquito. I don't know how loud this is going to come across on your end when you're listening to this because of the filters and things that I put on as I'm editing. I don't necessarily want to blow out your ears or anything, but just listen to how much this sounds like a jet engine powering up as I turn on the system and it powers up this device. So yeah, this particular device, I've already tested it and it's bad. I don't even remember if it shows up in the list. Oh, yeah. I'm just going to shut it off. I don't know if you could hear that, but it's rumbling. I mean, it sounds like things are flying apart here. But yeah, this particular drive just sounds crazy loud. Long gone. And I just wanted to point out again, a different type of termination resistor pack on this particular device. It's more almost like an IC. And so I'll be popping this out and saving it in case I need to use it in the future. But yeah, these terminators come in all sorts of different packages. So the last thing I wanted to show from the SCSI testing is that this box of random drives had a IOmega Jaz drive, an internal IOmega Jaz drive. And all the internal IOmega Jazes, I believe, were SCSI. But the interesting thing that I found out is actually these don't support self-termination or even have a connector back here anywhere for termination. So they shipped with a SCSI cable that had a terminator on the end of it, and that's what you would use. It does have some option jumpers, it looks like, over here, but no termination, unfortunately. So let's just attach this and see what happens with an unterminated device when you power up the system. Okay, here is the SCSI utility, the BIOS that's on there. Let's see what it detects, if anything. Okay, so it does say there's an insufficient termination detected. And if we do Control A, can we go in? Yeah, we can go in and we can go to the disk utilities. It's going to do the whole scan. And it does see an IOmega Jaz 1 gig. And it gives me the opportunity to format the disk or verify the disk, but I'm not sure if it would work if it's not terminated. So it comes up right away and says it detects an unterminated device on the chain. So I went ahead and picked up a couple things on eBay. Number one, I picked up this longer SCSI cable that has multiple spots for devices on here. The other one that I was using just had a single device allowed. And the reason I want an extra one is because I also picked up this 50-pin terminator on eBay as well. And this should allow me to plug into this extra connector here, just like it would have come shipped from the factory. And I should be able to terminate this here. And then hopefully when we reboot, it will show me that it won't give me that problem of the device not being terminated correctly. And here's just a close-up of what that terminator looks like. It's got a female on one side and a male on the other side. And the termination is going to be in between so that you can hook it up in multiple ways. Okay, it did not give me the termination error. It sees the Jaz drive on ID 4, which is a set 4, I guess. So no problems. Now, I've never run a Jaz drive on Linux before, so I'm not sure exactly what's going to happen, but let me go get a Jaz disk and we'll see if this thing works. Well, I did find a 2 gig disk, not a 1 gig disk, but a 2 gig disk, and unfortunately it says this data or this disk for use only with the 2 gig drive. And I did try to go ahead and insert it into this 1 gig drive, and it wouldn't even let me. It must be keyed somehow to only allow the 1 gig disks in that drive, or they keyed the 2 gig drives differently. So let me look around and see if I can find a 1 gig drive, but if I can't find a 1 gig disk, then we might be stuck here. Well, unfortunately, I can't find a 1 gig Jaz disk. So I looked through all my stuff. I couldn't find one, but I have every indication that this will work, assuming I can find a 1 gig disk to test in this. Well, there could be mechanical problems, but in terms of finding the drive and software, I think it'll work, because let me show you another quick, if you're not used to Linux, another great thing you can do to search through text documents easily. So remember that dmesg command? I think I showed it before. So I can do dmesg and then pipe that to another program called grep, command line program called grep, and I can grep for basically the letters, the word SCSI here. So I'm basically going to search through the dmesg output and look for the word SCSI in the result and then just output those to the screen. And if I do that, I actually had already done it, so it's still up here. But if I do that, I can definitely see when the system was booting, not only did it find the SCSI adapter, but then it also says right here, 8040 direct access IOmega Jaz 1 gig. So it does find the drive hardware at least. So if I can get my hands on a 1 gig Jaz cartridge or Jaz disk, then I can validate if this thing's working. Wouldn't it be cool to add the internal Jaz drive to my floppy test rig and have actually not just 4, but 5 drives working in there simultaneously by putting in a SCSI card and this IOmega Jaz drive in there. And then I could have something to really test, one more thing that I can throw at it. So I might do that in the future, but first I've got to get my hands on a disk that I can actually test this thing with. Now, I decided I'm not going to test the MFM hard drives out in this episode. I might do that in a later episode, but I don't have a high degree of confidence that these will work, since they literally came in at e-waste in a 5-gallon bucket just thrown in there, or the guys at e-waste tossed them in here playing some basketball with the drives or something like that. So I have very low confidence that these are going to work, but I will keep them and test them. If you want to see someone testing MFM hard drives, I'd recommend Adrian's Digital Basement. He's done multiple tests on the MFM and RLL hard drives. So in the meantime, before I get around to these, if you want to see drives like this being tested, head over to Adrian's Digital Basement and search for MFM hard drives, and you should find his video on that over there. So all in all, I got, I believe, out of all the drives I had, I got about a 60% working rate, 60 to 70% working. I got about half of the IDE drives to work. Well, these are the SCSI drives. I had a tower like this where I had about half or 10 or 11 of the IDE drives were working, and about the same number of the same ratio anyway of the SCSI drives I was able to get working. So the nice thing is now I could throw these into a Macintosh SE, SE30, LC, you know, all of those Mac and Mac 2 type of computers that supported SCSI drives. I can throw those in there and get them up and running if I want to. They will eventually go bad because it is spinning rust, but same with the IDE drives. If I just want to, for nostalgic reasons, throw in an actual spinning rust hard drive into one of those systems, I can. I'm not saying you should do it, but you can do it, and now I know which drives are working and which drives aren't. I'm actually pretty excited to test out these IDE Bigfoot drives in a system, so I'm definitely going to be, next time I need to pull out an IDE drive, I'm going to pull out one of these Bigfoots, and I guess the performance is kind of crappy on them, but you know, they're just so unique and interesting, and really a piece of history from hard drive technology. So I'm going to put a link on the screen with some other videos that are IBM PC related if you want to check those out, and I'll see you over there in the next one.
End of line.